Hi students, in this session let us learn magic T or hybrid T. So why it is called as hybrid T means it is a combination of both E and H plane. So it is called as EH plane T junction. Okay. So this is the geometrical representation of magic T or hybrid T, where it having 4 ports. Port 1 and port 2 are collinear arms, and port 3 is the E arm, and port 4 is the H arm. Okay. Now it is a combination of E and H plane, so that the properties also can be used. Both E plane properties and H plane properties are used together in magic T. So what is E plane property? E plane property is whatever the input is applied it, that is equally divided between port 1 and 2 having 180 degrees phase shift. Similarly, H plane. So whatever the input is applied at H arm, that is equally divided between port 1 and 2 and having in phase. In phase means there is no phase shift, that is 0 degrees. Okay. If you want to learn E plane T junction and H plane T junction, there is a links in description. Please go through it. And now you have to determine the scattering matrix for magic T. So first step is you have to determine the size of the matrix. So to find the size of the matrix, you require number of ports in this T junction. So here number of ports is 4, then the size of the matrix is 4 by 4. 4 by 4, so that you can write the S matrix for this is first row S11, S12, S13, S14. Second row S21, S22, S23, S24. And third row S31, S32, S33, S44, S34. And fourth row S41, S42, S43 and S44. Okay. So here it consisting of 16 elements. You have to determine these 16 elements by using both H plane properties, E plane properties along with this scattering matrix properties, S matrix properties. Okay. So by using all these three H plane, E plane and S matrix properties, you can easily determine this 16 elements in the S matrix. Okay. First go with the E plane and H plane. So first coming to the arms. H arm is port 4. E arm is port 3. Okay. So here port 4 and port 3 are perfectly matched, means no reflections. No reflections means perfectly matched. Perfectly matched, so that you can write it as S33 equals to 0, S44 equal to 0. Okay. Next, according to the definitions of E plane and H plane, so here H plane, H arm is port 4. So due to this port 4, if input is applied to port 4, so this is H arm. So the power is equally divided between port 1 and 2 and having in phase. So this can be represented as input is applied at fourth port and power is equally divided to port 2 and 1 as 2 equals to 0. Similarly, coming to input is applied at to port 3. Port 3, what is port 3? Port 3 is a E arm. E arm means, so you are getting the equal power at port 1 and 2 having out phase. Okay, out phase. Out phase means 180 degrees. Okay, so 180 degrees you can represent it as input is port 3 and you are getting output from port 1. Similarly, input is port 3 and you are getting output from port 2, which are equal in magnitude but out of phase. Okay, next, one more step and one more property. So here port 3 and port 4, that means H arm and E arm are isolated to each other. Isolated to each other. So what is meant by isolated? Isolated means here if input is applied to port 3, so no output from port 4. Okay, so you can write it as S34. So S43. So input is this port 3 and output is port 4. So no output, so you can write it as 0. Similarly, if you apply input to port 4, no output from port 3. Why? Because it is isolated. So that as input port is 4 and output port is 3, there is no signal, means you can mention it as 0. Okay, so with this properties of and the for E plane and H plane and geometrical representation of E plane and H plane, we have determined these elements in S matrix. Okay, now let us go with properties of S matrix. The first S matrix property is symmetry. Symmetry means Sij equals to Sji. Okay, so you have to use symmetric property of Sij equals to Sji. So you can write it as S12 equals to S21, S13 equals to S31, S14 equals to S41, next S21 completed, 22, 23, 23 equals to S32, next S24 equals to S42, next 31 completed, 32 completed, next S34 equals to S43. Okay, next 41 completed, 42 completed, 43 completed. Okay, now due to symmetry you can equate S12 S21 like this, so that finally you can rewrite this new S matrix by considering all these properties together, E plane properties, H plane properties and S matrix symmetry property. Okay, now we can rewrite the S matrix S11, S12, S13, S14. Second row S12, S22, S13 minus S14, S13, S13, 0 where S33 equals to 0 and S34 equals to 0, S14 minus S14, next 0 and 0. Okay, so this is our S matrix, new S matrix. Now we have to use one more property of S matrix is unitary property. Unitary property. In unitary property, the product of S matrix and its complex conjugative is equal to identity matrix. Okay, so here the size of the identity matrix is 4 by 4 and you can do it. So what is S matrix? S matrix is S11, S12, S13, S14, S12, S22, S13 minus S14, S13, S13, 0, 0, S14 minus S14, 0, 0. And coming to complex conjugative of S matrix is S11 star, S12 star, S13 star, S14 star, S12 star, S22 star, S13 star minus S14 star, S13 star, S13 star, 0, 0, S14 star minus S14 star, 0, 0, which is equivalent to a identity matrix 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Now you have to do the row and column multiplications, okay, one by one. First we have to take the row 1 and C1, column 1, so R1 and C1, okay, row 1 in S matrix and column 1 in complex conjugative S matrix. Okay, so you get S11 into S11 star plus S12 into S12 star plus S13 into S13 star, S13 into S13 star plus S14 into S14 star, which is equivalent to 1. You can rewrite this as modulus of S11 square plus modulus of S12 square plus modulus of S13 square plus modulus of S14 square equal to 1. This is equation 1. Similarly, you have to do for R2 and C1. C2. Okay. So if you do like that, what we get? We get S12 modulus square plus S22 modulus square plus S13 modulus square plus S14, okay, which is equivalent to 1. So treat it as equation 2. And next, coming to row 3 is multiplied with column 3. So what will happen? S13 into S13 star, okay, S13 into again plus S13 into S13 star, and remaining 0 into 0, 0, so that it is equals to 1. So you can write it as S13 modulus square plus again S13 modulus square equal to 1. So you can write it as 2 S13 modulus square equal to 1. So you can write it as S13 equals to 1 by root 2. Okay. If S13 equals to 1 by root 2 means S31 is 1 by root 2. Okay. At the same time, S13 equals to 1 by root 2 means you can write it as, according to E plane, it is minus S32. Okay. Next, coming to R4 and C4. R4 and C4, what we have to do? We have to do the R4 multiplied with the C4. Okay, we will get S14 modulus square plus modulus of S14 square equal to 1. So you can write it as 14 modulus square equal to 1. So therefore S14 equals to 1 by root 2. Okay, so with this we get S14 and S13. Okay, now next step is you have to compare the equation 1 and 2. Okay, same as E plane and H plane only. Okay, but here the size of the matrix is 4 by 4. So compare equation 1 and 2. So see, let's go to equation 1. See here in equation 1, so here we having S12, here also S12 square, and next S13 square, S13 square, S14 square and S14 square. So the difference is in equation 1 we having S11 square, in equation 2 we having S22 square. So that from this we have to conclude that, what we have to conclude, modulus of S11 square equals to modulus of S22 square. Okay, so we can write it as S11 equals to S22. Okay, now let's take equation 1. Okay, so what is equation 1? S11 modulus square plus S12 modulus square plus 1 S13 modulus square S14 modulus square equals to 1. So modulus S13 modulus square plus S14 modulus square equal to 1. So now already we know that what is S13. S13 equals to 1 by root 2 and S14 equal to 1 by root 2. Just substitute this, you get modulus of S11 square plus modulus of S12 square plus this is 1 by root 2 whole square plus 1 by root 2 whole square equal to 1. So you can write it as S11 modulus square plus S12 modulus square. This is 1 by 2 plus 1 by 2 equal to 1. So 1 by 2 plus 1 by 2 which gives 1, and here we having at the right hand side we having 1. So 1 cancel, and finally you are getting S11 modulus square plus S12 modulus square equal to 0. Okay, now see, now you are adding two square terms, S1 square and S2 square. So always this should be positive and this is also positive. If any two positive terms are added, you are getting 0, means you can conclude that only one condition, both this equation is satisfied when both S11 equals to 0, S12 equals to 0. Otherwise this condition is not satisfied. So that S11 equals to 0 and S12 equals to 0. Okay. So from equation, what is equation here? From this equation comparing 1 and 2, you got S11 equals to S22. It means that S11 equals to 0 means S22 is also 0. Okay. Now with this we calculate all the elements, 16 elements in the S matrix. Now you have to rewrite the final S matrix with corresponding numerical values. That is 0, 0, 1 by root 2 plus 1 by root 2, 0, 0, 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2, 0, 0, 1 by root 2 minus 1 by root 2, 0, 0. Okay. So if you want to represent in terms of input ports and output ports, you can write it as matrix B equals to product of S matrix with the input ports. This is output ports, this is scattering matrix, this is input ports. Okay, so you can write it as, here it we having 4 ports, output ports B1, B2, B3, B4. Okay, this is scattering matrix. Scattering matrix 0, 0, 1 by root 2, 1 by root 2, 0, 0, 1 by root 2, minus 1 by root 2, 1 by root 2, 1 by root 2, 0, 0, 1 by root 2, minus 1 by root 2, 0, 0. Okay, into corresponding matrices A1 input ports A1, A2, A3 and A4. Now you have to write the corresponding output equations, that is B1, B2, B3 and B4. Okay, what is B1? B1 equal to A3 by root 2 plus A4 by root 2, and B2 A3 by root 2 minus A4 by root 2. B3 A1 by root 2 plus A2 by root 2. And what about B4? B4 equals to A1 by root 2 minus A2 by root 2. Okay. Now, to determine whether the magic T is satisfies the E plane, H plane and combination of both, let us consider 2 cases. Okay, the first case is, let us assume that input is applied to port 3. So the first case is case 1, input is applied to port, applied to only port 3. Okay, port 3, that means A3 is not equals to 0 and remaining A1 equals to 0, A2 equals to 0, A4 equals to 0. Okay, now what will happen? What will the result of B1, B2, B3 and B4? So B1 equals to, what will happen? B1 equals to A3 by root 2 and B2 equals to A3 by root 2 and remaining B3 and B4 becomes 0. Okay, now B1 equals to A3 by root 2 and B2 equals to A3 by root 2 and B3 equals to 0 and B4 equals to 0, which satisfies the what is this? This is a E plane. Okay, why? Because we are applying input to port 3 and you are getting the equal E plane or H plane? H plane. This is H plane and here same power will be divided between port 1 and port 2 and having same phase. So in phase. And similarly case 2. Coming to case 2, you have to take the input is applied to port 4 and only port 4, then A4 is not equals to 0. At the same time, no input at port 1, 2 and 3. So A1 equals to A2 equals to A3 equals to 0. So that B1 equals to A4 by root 2, B2 equals to A minus A4 by root 2 and B3 equals to 0 and B4 equals to 0. Okay, so which can satisfy the E plane? E plane means where power is divided equally and having 180 degrees phase shift. Okay, phase shift, 180 degrees phase shift. Okay, so the magic T satisfies both E plane and H plane. Okay, this is about what is magic T and geometrical representation of magic T. How to determine this 4x4 matrix which having 16 elements by using both H plane properties, E plane properties and S matrix properties. If you like my teaching, please like, share and subscribe. Thank you.